Excellent. Good morning. Very happy to see all of you here. My name is Oleg Šelajev, and I come from Estonia, and I work as a developer advocate on the GraalVM team at Oracle Labs at Oracle. And if you have any questions that you will not get the chance to ask me here, I encourage you to find me on the internets and almost universally go by @Šelajev, so you can tweet at me or GitHub issues me or I don't know, find me on LinkedIn and ask all your uncomfortable questions about GraalVM and JVM languages and life in general and well, like everything. Oracle Labs is a research and development institution within Oracle, so its goal is to actually do science, right? To push the boundaries of what we know about the computer science and how to write virtual machines and how to write programming languages and whatnot, and then eventually to convert that accumulated knowledge into the products for the industry, so we as an ecosystem could benefit from them. So GraalVM is one project that is coming from Oracle Labs, and today we're going to talk about this and how it can help Kotlin developers and in which scenarios you would like to use GraalVM as a runtime and what it can do. This is a technical presentation, so please do not make any forward-going business decisions based on contents of this. This is very important. And with that legality out of the way, let's talk about GraalVM. How many of you have heard of GraalVM? Excellent, very good, very good. As a developer advocate for the project, it makes my heart very warm and fuzzy that all of you kind of heard of GraalVM. How many of you think you can explain what GraalVM is? Right, actually more people than usual. Very good, very good. But for the rest of you, you are in the right place, right? Hopefully after this short session, we will learn something. And you are more comfortable explaining to other people and understanding what GraalVM is. In one sentence, it's a high-performance polyglot embeddable virtual machine for running programs in different languages. So it's a little bit a complex sentence, right? There are a lot of unpack, but it's high-performance polyglot virtual machine. So GraalVM would like to offer you the following things. The vision for GraalVM is to run programs in all kinds of languages, Kotlin, Java, JavaScript, if you will, Ruby, Python, to run them efficiently, to run them faster than the alternatives could do, and also to make developers more productive by providing this unified runtime environment for all the languages, right? So it's a common platform, and we would like it to become an ecosystem. So all the languages and all the communities writing software in different languages could kind of work together rather than point fingers at each other and laugh about how one part has null pointer exceptions and the other has undefined is not a function or similar problems. So let's all be friendly. GraalVM project goals and the value that you can get from using GraalVM today is that we run languages that we support quite fast, and you can get specifically for the JVM languages and specifically for you for running, say, Kotlin on the JVM, you can get higher performance than otherwise. There is a ahead-of-time compilation mode for JVM-based languages where you can get your application to the native binary, not unlike Kotlin native, but for like the JVM-based languages, including the Java platform. And that could be used in cloud environments where you need faster startup and lower memory overhead. You get the interoperability between languages, which means that you can write your systems in different components in the system in different languages, right? So you can have your Kotlin application, and then you can spice it up with some machine learning in Python. And you don't have to like erect a boundary between those two languages, right? You can use them in the same process, and you can use them efficiently. So there is no memory copying or object copying between those. You just use your Python script that your data scientist has wrote for you as it would be like a part of your normal library. And the tooling that works for languages. And also the embeddability in native and JVM applications. So if you have a platform, like a large platform that does a lot of things, and besides you would like to extend its capabilities with small programs in other languages. For example, you have something like some sort of space, right? And then you would like to extend that with plugins written in, not just in Kotlin, but potentially JavaScript. Because there are like almost anything you would wish to ever write has been written in JavaScript. So maybe you can just reuse that code. So GraalVM could offer you a runtime where you'll be able to customize your large application with this particular ability to run, say, JavaScript or Python efficiently. So if you have large platforms, if you have large applications that could become polyglot, then you should look at GraalVM. But mostly, and the most well fleshed out stories currently for GraalVM is the higher performance and the low footprint mode for applications. And of course, that means that we are concentrating on the server side of things, right? So GraalVM is a runtime, not unlike a JVM, and it includes a JVM, but we are gonna target server side. Initially, when I was preparing to come here, I thought that as a big story in the Kotlin ecosystem. And well, yesterday, Andrea at Keynote explained to me that Kotlin ecosystem was much larger. So I feel like this is very important to concentrate. Currently, there is very little that GraalVM can offer for you for, say, mobile development. There are some experiments, but we're gonna touch on that. So we're gonna concentrate on server side. What GraalVM is, it's a polyglot runtime, and we have a number of languages that we support, right? So JVM languages, including Kotlin. We have Ruby, Python, JavaScript, R. We have native languages that go through the LLVM toolchain. We also have an experimental support for WebAssembly. So if you would like to execute some WebAssembly, you can run it on GraalVM as well. And as I said, you can run it in different environments, in different modes. You can run it inside your JVM. You can run it inside a proper node instance, and you would have your node event loop and whatever. So if you have colleagues who write node applications and you would like to share the joy of using a Kotlin library with them, you can use the runtime that can execute both. There is a standalone mode for this AOT compilation, and you can embed it in large applications. And there are some experimental builds of the Oracle database where GraalVM can be used for running stored procedures as JavaScript, which is quite interesting. Right, so GraalVM is a large project. It's an open source project. And it consists of several very important parts. There is a core of, altogether, it's a little bit more than 3.5 million. And this is a rough estimate, right? We didn't actually count lines of code and verify that this is a useful line of code versus like a curly brace or something. So it's an estimate. But there are a large chunk, which is the compiler, which is at the heart of the GraalVM project. This is a just-in-time compiler for JVM bytecode. Can be used as a ahead-of-time compiler as well. There is a framework for implementing managed languages called Truffle. There is a runtime bits, like garbage collection, that will go into the platform binary when you compile ahead of time. And there is, of course, support for the existing languages. And as you can see, there is no WebAssembly even yet, because we added that just recently. And also some tooling. So for the polyglot story, it's very important that you do not get into mess that you cannot debug or you cannot profile your application written in different languages, right? That would be kind of unfortunate. So GraalVM provides tooling for that as well. But for JVM languages, and I'm gonna boldly assume currently that Kotlin is a JVM language, despite other platforms for Kotlin as well. GraalVM offers two main advantages, right? It can run as a Java, and it can run as the platform binary. And both of them offer you different performance impact, and you would be interested in using them in different contexts. So we're going to talk about the running as a normal Java process in the JIT mode using just the normal Java hotspot VM, where GraalVM replaces the C2 compiler, the top-tier optimizing JIT compiler. It replaces with the GraalVM compiler. Right? So it's a normal, when you run Java from GraalVM, you download GraalVM, you unpack it, you type GraalVM/home contents bin Java, right? It starts normal Java hotspot virtual machine. that comes from the OpenJDK project. And then you can run, and you can, the benefit of using GraalVM is that the compiler has very good high-level optimizations, right? It might not have the best low-level registry allocation yet. We will get there eventually. Or like the bit fiddling techniques. But what it shines at is at high-level optimizations, which allow you to write highly abstracted code that you don't have to suffer from performance impact, right? So if you would use something in Java, right? Or I'm not sure actually how to translate this idiom into Kotlin. Unfortunately, I don't have enough Kotlin experience. But the idea is that very often we try to structure a code in a defensive manner, or restructure a code to be more performance aware, right? So for example, if we know that some logging is disabled, then before calling the log function and passing the parameters and making it evaluate everything, and then do nothing because the logging is not enabled, we actually wrap it up in another if block. And this is a very common idiom. Or there is another stuff where we know that we would like to use high-level abstraction utility functions, right? But we know that the performance-sensitive code is something, and we would rewrite it to actually kind of like manually inline the contents of the utility that we would like, right? And I hope you recognize, at least not even if those particular examples, but the idea that sometimes as developers, we think that, oh, our runtime will not be smart enough to offer the best performance. So we need to help it with doing kind of like ridiculous tricks, right? This is something that the runtime should do for you. So Chris Newland, who is a performance expert and wrote a couple of books on performance, says that for his team, he says that please do not use any high-level abstractions. No functional programming, no advanced object orientation. So does that mean that you should not use like higher abstract languages as well, right? You should not use Scala or Clojure or Kotlin because you will get performance impact. So as the runtime developers, for us, this is kind of unfortunate. So the GraalVM vision is that the runtime should be smart enough to allow you to write code in the way that you want. If you want factories, you should have factories in your code. If you want stream API processing, and if you want reactive streams, you should write your code using reactive streams. You should not think about whether a for loop or a stream-based approach is faster, right? Because that is a job for the compiler to figure it out. So, and GraalVM makes steps to achieve that vision, right? So obviously, no one is perfect, and you can always have a limit somewhere for the abstractions, but we are making steps for that. How you can do that? You can download GraalVM. It comes as a JDK distribution. You can open that, add it to the PaaS, and run your Java applications normally, and your Kotlin applications normally, and hopefully it will be faster. And I'm going to run one benchmark here just for you. And it's not a scientific benchmark, but I just want to show you some results because I hope it's kind of like very interesting. It's kind of very interesting. Let me remove this. So it's a very simple benchmark. So we just have a bunch of integers, and we just would like to convert them to a sequence and to map a couple of functions over that and just reduce that. It's a very simplistic kind of synthetic code, right? But I just want to give you a short example because I can run it in front of your eyes, and you will see that there is no trickery involved. Hopefully, right? So it's a JMH benchmark, and originally I wanted to show you the benchmarks that Roman is showing in the main hole, where he compares Kotlin Flow to other implementations of the reactive streams to show that Flow is better. And he has benchmarks to kind of prove that. And I wanted to run those benchmarks and show you the difference that the GraalVM runtime makes on those. But there is one issue with the loops inside Kotlin coroutines, which is currently outstanding. And I'm gonna touch on that a little bit later. So unfortunately, I couldn't. So we're gonna run this synthetic benchmark. And I'm gonna run this normally, and I'm gonna run this using my Java command. So for the tricks, I will do which Java, right? And this is my Java, and this is Java 8-based distribution of GraalVM EE. So I'm going to run my benchmark here with C2. Right? To do so, I will disable. I will still run the. View presentation mode. Wait. Sorry. Where's my terminal? Okay, exit presentation mode. Sorry about this. We're not gonna bother with this anymore. Where's my terminal? Exit presentation mode. Terminal. Doesn't matter. I'm gonna run this benchmark, and I'm gonna not touch my computer for 40 seconds or for 2 minutes for some time, just to show you the results. And I'm gonna talk about what happens behind the scenes. So I'm using the hotspot as it is, but I'm using it from the GraalVM distribution. But I'm also disabling the GraalVM compiler. So currently, this is the setup as you would get when you would run with the JDK, normal open JDK, with C2 as the top-tier optimizing compiler, right? We're gonna wait like a little bit more, but you can see that the results are stabilizing to a certain extent. So don't trust this benchmark, right? First of all, because this is a benchmark that I'm showing you from stage, so you know that there is some marketing component involved, absolutely, and it's not just because of me, because I'm like sneaky Oleg for you here. It's anyone. When anyone shows you benchmarks from stage, take them with a grain of salt, right? You always have to interpret the benchmarks and understand what's happening there. And this is not a rigorous benchmarking environment. This is my MacBook from several years ago. It runs Docker. It runs with additional screen. There is turbo boost and whatnot. So you know that these results are not very scientific. But also these results that I'm going to show you are a little bit understandable, that you can extrapolate. Hopefully you will see the difference and you will be like, this is interesting. Maybe I should look into trying GraalVM. So I'm going to stop it. You can see that the numbers kind of stabilized approximately near the 1,500 operations per millisecond. So what we do? Where's my? No, wait. Simple benchmark here. So we run this benchmark 1,500 times a millisecond, right? And you can see when I start moving my mouse, the performance drops. But doesn't matter. So now I'm going to run the same benchmark, but I will not disable the GraalVM compiler. And my Java from my GraalVM will use the GraalVM compiler as the top-tier JIT compiler, and I'm going to run, and hopefully it's going to show us a little bit better numbers. So we had 1,500 operations per millisecond, and now in 10 seconds, hopefully we'll see a number which is what? Which is a little bit higher than 1,500 operations per millisecond. And so it will also stabilize somewhere in the 18,000 operations per millisecond, and this is a very surprising result because JVM, as it is, the normal JVM, like hotspot, is a state-of-the-art virtual machine, right? We use it and we know that it runs and it makes code really efficient. But the difference that the GraalVM compiler can make is very significant, especially when you run code that is more abstracted than a single loop that runs over the array of primitive doubles or something. So here in this example, we create a sequence, we lazily map functions over it, so the data has to flow. There are intermediate objects which are created, and it's a complex bit of code actually. And you can see that other compilers could struggle with it a little bit. So you will not see this type of performance boost when you run your actual application, right? So it's a little bit ridiculous to assume that you can run it 700 times faster or something. But you will see a difference, specifically if you write in different languages than Java, right? So because the bytecode patterns that Kotlin produces, or that, for example, Scala produces, or that Clojure produces. They're a little bit different from the bytecode patterns that the normal Java programs produce, right? So Java programs and C2 compiler kind of grew together, and they made sure that they are kind of optimized for each other, right? So that's why your Java programs could run better on C2, and the performance boost there could be less significant. For Kotlin programs, which are typically like a little bit higher in abstraction usage, you can see better results. And for the other JVM languages, or if you just use abstract concepts. So GraalVM optimizations, the optimizations that GraalVM does here, which allow this, is we have really, really strong inlining. So that means that we can actually see through all of this and kind of inline that into doing nothing, right? So it doesn't actually lazily have to create and evaluate the map functions all the time. And escape analysis. So we don't have to create objects all the time, because GraalVM can figure out that when the objects are not used, and it uses a much more pragmatic policy for that than C2. So C2, for example, has to make sure that the object doesn't escape the current local memory, and no one else can see it on the meta level, right? And the GraalVM can do that in a conditional. So if an object escapes on one branch of a conditional, but doesn't escape on the other, so we can avoid allocating this object until it actually has to be allocated. Right? So this allows us to remove the garbage collections, remove the object allocation pressure, because we don't have to create objects. Sometimes we can more operate on the primitives rather than boxed integers and numbers. So all in all, escape analysis and better inlining give you performance boost here. Obviously, GraalVM compiler implements all other normal optimizations like anyone else. The dead code elimination and the loop optimizations and the deduplication and copying pieces of code to avoid megamorphic calls and whatnot. So it's a state-of-the-art compiler, and you can use it very simply from just by downloading the thing. So there is no reason not to try what I'm trying to say. And of course, we run tons of benchmarks. We run more benchmarks than just simple synthetic test on a poor MacBook on stage. And we also know that the GraalVM compiler offers a very good competitive performance, right? GraalVM can come in two versions. There is an open source project, which it's a fully open source. You can try, build, run it, and it shows good results. And then there's a GraalVM Enterprise, which is a product by Oracle, which shows even better performance because it comes with additional optimizations and enhancement in the compiler. But you can try, obviously, both. So if you look at the benchmarks, and if you want to see more benchmarks than just some sample code, we have this suite of benchmarks called Renaissance, which GraalVM team, some people would know the GraalVM team helped some universities to create. So it was a joint effort. And the goal for that was to run more modern JVM workloads than other benchmark suites do normally, right? So if you look at the benchmarks that we normally run as an industry, they are a little bit older than maybe some projects that we currently are working on. Right? So if you look at Spec JVM 2008, it was created around 2008, right? Or Da Capo or something. And then several years ago, we wrote our JVM applications differently. For example, probably you didn't write any JVM applications in 2008 in Kotlin. So we wanted to create a different benchmark suite that kind of exercises maybe other parts of the JVM that other benchmarks do not, right? So to show performance on the more modern workload. And here in the Renaissance, you can see there is some Akka, there is some compilers like Dotty for Scala, there are some Neo4j for data analytics, and some other benchmarks which are maybe less represented in more typical benchmark environments. That said, more benchmarks is always good, because running just a few benchmarks means that you will make sure that you run those really, really well, but then you will see the real-world code, and you will be kind of confused by the results, and your compiler will be confused by the results, because it has never seen the code like that, right? Because you overfit it for particular benchmarks. So benchmarks are good We think as the team that more benchmarks are always good, right? That's why we started Renaissance. And also, it's very important, you have to realize that benchmarks are not the substitution for running tests on your code, right? I can give you a number, a single digit, like how much better the GraalVM is than, say, OpenJDK, or how much better GraalVM Enterprise Edition is than the Community Edition, and it will mean nothing to you. It will be the average temperature in the hospital, because there is a number of workloads, they have different performance characteristics, and you just combine that into a single number. So what you should do, you should look at your code, you should look at your applications, you should try it, or maybe try it on the sample applications that represent your workload, and then you extrapolate those results. So while more benchmarks is good, there is no going around that trying it on your code. And one thing that you can do, and one thing that we would encourage you to do, is if you see some results that are maybe less than excellent, and you would like to make something faster, then you do not rewrite your code to use like lower level of abstractions. You don't remove your object hash functions and rewrite them in multiplication of integers, right? But you try to solve this problem in a more general way. And the more general way would be to collect the profile that your runtime has when running this code. For example, the Java flight recorder information, and then just share that information with us, right? We can look at that. We can, if you share the flight recorder information on GraalVM and say on OpenJDK, we can see look at the differences. We can see whether there are potential for the optimizations, and we can make it better for everyone, not just for your particular project, right? So, for example, maybe we can make the Kotlin compiler faster, just because. Probably not. People are not convinced. I think we could by providing a faster runtime for that. Maybe not. But maybe that with the new compiler coming, maybe that will be unnecessary. So what I wanted to say, talk to us. If you want some code that to run faster, we would be happy to look into making it faster, right? On a general basis. So this is it. This is how you use GraalVM in the JIT mode, and you get the peak throughput, and you also get the latency of the normal garbage collections in the JDK. Right? So when we talk about performance, it's very important. There are different people. I have time, right? I have 20 minutes. Very good, very good. The applause there kind of threw me off, because we have the material to cover. We should warm up. We should become more efficient at going through the material. So when we talk about performance, different people mean different things. And we learned about that when we went out to people and say, oh, GraalVM is such a great thing. It offers the better performance. And people are like, I write in Go. It starts up fast. So peak performance is one axis for performance. Startup is another one. The low memory footprint is an aspect for performance, which is the most reasonable in the cloud, because there you actually pay mostly for the memory, and everything else comes from the memory. Latency, some people care about packaging a lot, especially on the front end, right? When you don't want to ship the whole JVM to your browser. But on the server side, that could be like a little bit less exciting performance benefit. So in the JIT mode, you get great peak throughput because JIT has visibility into your system, right? It can optimize it to the best of the ability. You get great latency because it's an inverse of the throughput, typically. But the other numbers are maybe not so great, right? So specifically, the startup and memory consumption are a little bit less than desired because the JIT facilities need to allocate memory. They need to do work, right? So that means at startup, your JIT is doing work rather than your application. Sometimes it's not desirable. So the ahead of time compiled mode offers you different trade-offs for performance, right? The ahead of time compiled code will not need to execute JIT or initializations in the beginning of the work, right? So to have better startup, in the case of GraalVM native images, you don't depend on the JVM, so it gives you really, really good startup. You don't need to allocate memory for the compilation facilities, right? So you get lower memory footprint, especially pronounced on the small services. if you have an application that runs with like terabytes of heap, it doesn't make sense to try to save like 300 megabytes by not using the JIT, right? It's not worth it. But if your application is actually like a small server that takes some HTTP requests, writes something in Kafka, sends something to the database, transfers some data, outputs some log statements, and then returns the JSON to the user, which is a lot of use cases actually. Then maybe your application doesn't need to allocate like 300 megabytes or 500 megabytes for JITting purposes to serve that one request that comes in. So with an AAT mode, you get a different performance trade-off. But the good thing is the GraalVM project offers you both. Not at the same time currently, but it offers you both. So you can run it in a JIT mode, and you can run it in an AOT mode. What happens, there is a utility we call native image that can look at your application, and it takes into account your application, your libraries, your Kotlin jars, your JDK classes from the JDK, and some classes that form the runtime bits like GC, and then initialize the application and compile it ahead of time and output a native executable. Kind of very similar to Kotlin native. But the main difference from Kotlin native is that it actually can transform the applications and compile them when they use JDK facilities as well. Right, so it can compile Java as well, not just going from the Kotlin source to the binary. And there is quite heavy analysis going on, so and this process could take a little bit of time, and then you compile your application, but then the results is really good, right? It gives you great startup, and I'm going to show you, and it gives you the great memory usage. So let me go back to my console here. Right? And I have my application here, and it's not a Kotlin application currently, but it doesn't matter because we can transform any JVM bytecode, including the bytecode that Kotlin produces, modulo loops in the coroutines for the issue, and I can build this binary, and I can have the file that doesn't depend on the JVM, and that is just several megabytes large, and I can put it in an empty or very small Docker container, and I can start it very fast as well. And you can see it starts up in just milliseconds, which is very good results for the JVM-based language application. And if I start that, and you can see, I can show it to you in the browser. It's a small application that shows you quotes from a file. It just doesn't do much, but it is sometimes very representative of a small microservice. And I can show you that. Where's my activity manager? Activity manager. Not idea, of course not idea. What quotes up? And my memory. This application at runtime to serve a few requests takes 14 megabytes of RAM. This is the whole RSS of the process, right? It's not the heap. So I can run this application in very small environments, like in a very small pod in a Kubernetes, right? And it doesn't have to consume resources for that. And because it starts so fast, I don't have to actually have the warmed up instances. How many of you run Kotlin native applications on the back end? 4 people. How many of you would like to run Kotlin native applications on the back end, but like cannot actually because of reasons? Okay, maybe you should look into GraalVM. Maybe some of the reasons are because your applications depend on the Java libraries, and Kotlin native cannot handle that. And maybe GraalVM will be able to handle that. So very good, very good. You can see this is a simple application, and it gives you an example, an idea what you can achieve, right? So some technology behind that. So the native image operates under the closed world assumption. So all the bytecodes need to be seen at the generation time. Right? So there is no dynamic class loading after the compilation has happened, which kind of limits a little bit to which applications currently work well. Also, the dynamic parts of using the JVM require some configuration. So, for example, people always at this point freak out about like how I'm going to use reflection. but the reflection actually works quite well. You just need to configure that. Like it's at the static analysis point when we generate this binary, right? We cannot possibly figure out all the usages of reflection that you can't have. Like the reflection being a dynamic feature can always cheat static analysis. It's a fact. So it needs the configuration help from you to say, I'm going to use those classes through reflection. I'm going to take my model and I'm going to serialize that to JSON, and I'm going to use reflection for that. So please, the generator, take that into account. There was no problem with actually using reflection. The problem is was automatically determining which bits to include, which bits you can use for reflective access. So one thing is, I'm very happy that currently it's not only me who has to go to people and say that reflection works great, because there is this misconception that reflection doesn't work. So I'm very happy that other projects from the ecosystem kind of start to take interest in GraalVM. And Sebastian, who will be here during the next time slot, talking about Spring applications in Kotlin. He also experimented with Spring applications and GraalVM native images. And he publicly says that the native image has great support for reflection. So have no fear, reflection is supported. You just need to configure that. The best thing is you can embed that configuration in your libraries, in your jar files. I'm not sure if you can embed them in the clip files, but potentially we can do. And you can use it for the projects, mostly for the newer projects, right? If you have a large WebSphere-based Java web application, probably you will not be able to convert that to a native image. If you start a new project and if you write a small Spring, I don't know, some small Spring-based or Ktor-based application, then you probably will do. So native image, it starts really fast. It doesn't need that much memory. It doesn't use CPU at the time of execution. So you can see the red ones are the CPU usage. It only does that when it actually serves the request. You can also tune that, how much memory it uses. There are a number of microservices frameworks on the Java side, because I don't think very many people in the Kotlin ecosystem actually had looked at that. But I think Ktor works as a native image as well. So a number of options that you can use, a number of options that will give you the same benefits. So the startup in milliseconds, the memory footprint in megabytes rather than hundreds of megabytes. And with the current thing is that there is currently an issue with Kotlin coroutines with loops inside them. The GraalVM compiler cannot represent them well on the internal data structure level. So currently it kind of is slow in the JIT mode. And currently it just bails completely in the ahead of time compilation mode. But we're going to work on that. I talked to people yesterday because I wanted to figure out why this is happening still. Really, in May when I submitted this session, I really hope that we're going to fix this by the conference. But we were dealing with other things and currently not, that is still outstanding. But I think there is a technical solution that would work. It's just like we need some time to look into that and actually like make it work, right? But it's not a showstopper that it will never be supported. Actually, to be honest, like it also can be fixed on the Kotlin side, right? It's not just us. But it will have different trade-off, like impact trade-offs, right? So it could be better if we could fix this rather than Kotlin would change the code generation patterns. But we're working with those people, so we're going to fix it. And eventually, we would like to run the ahead of time compiled mode, kind of with a very similar peak throughput to the JET. So for the best performance, what you would like to do, and what we would like you to do as the runtime implementers, don't try to cheat the system and just like write code as you normally write. Specifically, try to write small methods, because the compilers are great at inlining them. So if you write small methods, we can inline them in different combinations. If you write large methods, it's very hard to kind of like pull the parts away from it, right? Which compilers can still do that to a little bit of extent, but like it's awkward. So small methods, good. Large methods, less good. Don't hand optimize your application, right? So try not to introduce those like code patterns that you think, oh, this is for performance reasons. If you want throughput, try GraalVM in the JIT mode. If you want the memory and startup, try GraalVM native images. GraalVM ecosystem is quite large, right? There are a number of components which are production ready and which we think are production ready. That includes the native image compilation. There are a number of experimental and a number of components which are even at a less than experimental phase currently. But you can see that we have a pipeline to kind of become a proper runtime for all languages. So Twitter is currently using us for their Scala workloads. They're using the compiler specifically, but it's us. Oracle Cloud recently started using the GraalVM, and they saw good numbers, specifically on the garbage collection times, so they improved the pauses very much. There is a collaboration between Oracle and NVIDIA for creating a language on top of GraalVM that will expose GPU kernels. So if you're interested in running something with GPU, but you never figured out how to use that from Kotlin, maybe you could use GraalVM. We can run Node applications normally. Our JavaScript is top-notch compatible. Our JavaScript is as compatible as recent Node implementations, which is a very good feat because JavaScript as a language, it's a very fast-moving target. So being compatible is good. We're also, other languages are a little bit less compatible with the existing ecosystems, mostly because of the native extensions, right? When you write in Python and you see something is slow, what you do, you rewrite the inner loops in C to make it fast, right? So we don't do that in Java. We don't do that in Kotlin because the platforms are plenty fast normally. Sometimes we do, to be honest, but like normally we don't do. And it's a much more established practice in the dynamic languages. Our packages or Python packages, you can check the compatibility on the website. We define that we take the packages and we run their tests. If the tests pass on the GraalVM as a platform, we think that we, as a platform, do everything that the package wants us, right? Because the tests pass. So you should try that. If you want, you can figure out how to get into the product relationship and maybe consider the Oracle GraalVM Enterprise Edition, which is an official product, which I personally think it was a great feat that we could release that in this May because it was not easy to finalize it as a product. Maybe it's a little bit less ambitious than JetBrains space in the functionality, but it could be maybe a very good platform for running JetBrains space, right? But you don't have to actually buy anything. It's an open source project. What you can do, you should download it. You should use it. You should try it on your code. You should talk to us. You should try mixing your Kotlin with some other languages. I have 3 minutes, and I have one short demo about this. And I'm going to show it to you in a second. So try it. We would like to hear the feedback. We would like to hear the performance results from you trying it on your workloads or similar workloads. Because currently, I think before this, we didn't have a lot of exposure in the Kotlin ecosystem, right? So we would like to see those numbers. Well, I have a good hope that we will show quite a speed up on Kotlin code for the same reasons that Scala gets speed ups, right? If you have colleagues who write Scala, how many people know people who write Scala? Very good. Point them towards the GraalVM. We have good results for Scala as well. How many people know people who write Node.js? Very good, very good. We cannot run JavaScript faster than V8 yet, but you can share the joy of having Kotlin libraries offered to them. So if you have to work together, if you have, for example, a Kotlin backend application and it uses React as a front end, and you would like to use the server-side rendering for React, right? Normally what you do, you'll set up another node process to render with React, and your node and your JVM will talk at the backend, burning CPU, right? So you don't have to do that. You can render your React application from your JVM, from your Kotlin application, and it will use your facilities normally. So I have just 1 minute here, and I'm going to show you this particular application because I recently learned how to do this, and I think it's mighty cool. So I have this Kotlin code, and I have this suspend function, right? So it will take the coroutines and everything. And in my main function, what I will do, I will try to establish the JavaScript builder, and I will try to execute that function, right? And that's going to work. Who thinks it's going to work? Yes, of course not. Of course not, because that function is a suspend function. So on the bytecode level, and as a JVM, like it works on the bytecode level, this function has 2 arguments, because there is the coroutine context that you have to pass to make this work, right? And your JavaScript doesn't know anything about the coroutine. So what we should do? What should we pass here? What's a notorious object in the JavaScript? No, there is backend. There is no window. Of course, undefined. So we're going to pass undefined from JavaScript engine to our Kotlin coroutine function, and we're going to see and try to see what it has, what it does, and it creates the Kotlin null pointer exception. I was told that Kotlin doesn't have null pointer exceptions. You had type null safety and whatnot. And to be honest, I was informed that in the recent releases, this was renamed just to null pointer exception to hide its, I think, to hide its relation to Kotlin. But no. So now, for people who have colleagues writing Node.js applications, you have a runtime to offer them the happiness of working with code that can produce Kotlin null pointer exceptions. Thank you very much. I actually let me don't do this. Don't clap yet. To make this work, you have to generate an async bridge, right? So that will just be normal method, and it will enter the coroutine scope for you, right? So if I do this, and then I would do hello, and then I will do get because it's completable future, this should produce me the result. This should pause for a second and then produce me the result of hello. Fingers crossed. Yes, result of hello. Excellent. So this way you can run it. Thank you very much. If you have questions, come to me, talk to me, find me online. It was very happy to see you here. Thank you.